Okay. You learned in chapter 7, guys, how you test a claim about the mean from one population or the proportion from one population. What we're going to learn in chapter 8, how to compare two means from two different populations. For example, if you want to test the effective of a medicine, you bring two groups. One group will take the medication and the other group will take no medication, and you compare the results, not just of the two groups. So now you have two groups. That's what chapter 8 is about. Let's say someone asks the question, who spent more time shopping online, women or men? We have two groups here. We have women and we have men. This is an example of what we're gonna cover in chapter 8. Who gets paid more, men or women? Now you have two population, guys. The first population is men salaries and the second one is women's salaries. So we have two population. That is the subject of chapter 8. You can see the title of chapter 8 is hypothesis testing with two samples. In chapter 7, you did hypothesis testing with one sample. So we're gonna do two samples. Okay. Here's what we're gonna learn in the first section. How to determine whether two samples are dependent or independent. An introduction. Okay, I'll introduce and how to perform the test. First, just like we did in section 7.2, guys, we introduce hypothesis testing for the population mean sigma known, and we use z-test. Here, we're gonna have two sigmas because we have two populations, sigma 1 and sigma 2. And if sigma 1 and sigma 2 are known, we're going to use a z-test, but it's called two sample z-test, not just z-test for one sample. So you're going to see, guys, there's this very strong correlation between what we did in chapter 7 and what we're doing right now. Let me tell you what we mean by independent samples. Two samples are called independent if the sample selected from one population is not related to the sample selected from the other population. So you can see those two samples, guys, they don't seem to be related. Look, they're standalone, each one of them. That's an example of independent. But look at the second figure. You see there is a relationship between members of sample 1 and members of sample 2 through the arrows here. So these are dependent samples. Let's do some examples, and guys, see if you have a good feel of what independent samples are. What do you think of the first two samples? Are they dependent or independent? Weights of 65 college students before their freshman year begins. Weights of the same 65 college students after their freshman year. Any answers, guys? What do you think? Dependent or independent?
Independent.
But look what it says. That means the students are related. It's the same group of students in both samples. And remember, when there is a relationship, it's the same group of students in both samples. The samples are dependent. Okay, let's clarify this and do some more. Scores for 38 adult males on a psychological screening test for attention deficit disorder. Scores of 50 adult females on a psychological screening test for attention deficit disorder. What do you guys think now?
Independent.
100%, 38 male, 50 female. They have nothing to do with each other. If you guys can track that the members of the first sample are the same as the members of the second sample, then they are dependent. But here they're two different groups, males, females, nothing in common, independent. Okay, I want to pause for 1 second, bring the book and do some more examples here because I wanted to understand. It's in section 8.1, number 5. The maximum bench press weights for 53 football players, that's sample 1. The maximum bench press weights for the same 53 football players after completing a weightlifting program. What do you guys think?
Dependent.
Dependent. It's the same 53 football players. Very good. Okay, what about 6? IQ scores of 60 females, IQ scores of 60 males.
Independent.
Independent, although it's the same number. They're trying to trick you here. 7. The average speed of 23 power boats using an old hull design. The average speed of 14 power boats using a new hull design. What do you guys think?
Is it independent?
100%. If the numbers don't match here, guys, 23 and 14, it's very 100% sure it can't be dependent. So 8. The commute time of 10 workers when they use their own vehicles. The commute time of the same 10 workers. You see, I stress on that when they use public transportation. What do you guys think here?
Dependent.
Dependent, exactly. Any questions, guys, about dependent and independent? Okay, that's good. We go to the next page. You're gonna like the way we state the null and the alternative hypothesis, and that's section 8.1. Okay, 2 sample hypothesis test with independent samples, sigma 1 and sigma 2 are known. All right. You know the null hypothesis, guys, must have the equal, less than or equal to, greater than or equal to. The alternative hypothesis must have a greater than, not equal to, or less than. Here is how you state the null and the alternative hypothesis for the mean in chapter 8. It's so easy, guys. We have a mean from population 1 and we have a mean from population 2. We are comparing means. Which one is bigger? Which one is smaller? Which one is larger? So here are the statements for stating the null and the alternative hypothesis in chapter 8. There are no numbers on the right, guys. In chapter 7, he will tell you test the claim that the mean is more than 70. So just put more than 70 right here. Here, no. He will ask you to test the claim that the two means are the same. That's it right here. Or he asks you the test the claim that mean 1 is greater than mean 2. There you go, right here. Or he asks you test the claim that mean 1 is less than mean 2, right here. So these are the 3 options for you to choose from, guys, in any hypothesis testing question in section 8.1. That's what they're going to be the case. So that's why I told you it is easier, because these are the only 3 choices that you're going to see. If he says test the claim that the 2 means are equal, that would be it. Equal, not equal. If he says test the claim that one mean is greater than the other, that would be it. This one, guys. And so on and so forth. We always assume that the null hypothesis is true until proven otherwise. Remember, the defendant is not guilty until proven otherwise. So we always try to begin our discussion with saying, let's assume HO is true, and let's find the p-value and see if we can reject HO or not reject HO. Okay. What are the conditions to perform a 2-sample Z-test? Z-test when sigma 1 and sigma 2, guys, are known. So Z-test, sigma 1, sigma 2 are known, and they're listed below anyway. The population standard deviation are known, as I just said. The samples must be random, they must be independent, and the population are normally distributed, or the sample size is more than 30. Remember, guys, from chapter 5, the central limit theorem requires either the sample size to be more than 30 if the population is not bell-shaped, and if the population is bell-shaped, it doesn't matter what the sample size is, it can be anything. how to perform the test. Verify the 4 requirements. And then look, guys, is this something that rings a bell? State HO and HA. Calculate the test statistic Z, just like section 7.2. Calculate the p-value. Make a decision to reject or fail to reject the null hypothesis. Interpret the decision in the context of the original claim. That's it. So, and let me show you guys that how to perform a 2-sample Z-test comparing 2 means. You ready for the first one? Let's do that. We'll do that together. I'm going to go step by step. All right. A credit card watchdog group claims there is a difference in the mean credit card debts of households in California and Illinois. The results of a random survey of 250 households from each state are shown at the bottom. The 2 samples are independent. Assume that sigma 1 is 1045 and sigma 2, sorry guys, that should be sigma 2 here, is 1350 for Illinois. Do the results support the group's claim? Okay, what do they claim, guys? That the mean that there is a difference. Okay, would you guys agree with me that our null and alternative hypothesis is going to be this? Difference means not equal. That's what it is. As I told you guys, you have to choose one of the 3 above right here. You have to choose either this or that or this. So just put them in front of you guys as you do chapter 8 and select, just the one that works. Couldn't be any easier than this. Are the conditions of the test met? Let's check, guys. Number 1, population standard deviation are known. Yes, he says sigma 1 and sigma 2. So that's the first one. Let's see condition number 2. The samples are randomly selected. Do you see anywhere, guys, where it says the samples were random? Can a student tell me?
Yeah, it does say the results of a random survey of 2.
Thank you very much. That's number 2, checked. Then he says independent samples. Does it say anywhere, guys, that the samples are independent? I think you can see it, guys.
Yeah.
Yep. And the population are normally distributed, or each sample is at least 30. Well, we have 250, so we're good. We don't care if the population is normally distributed or not. We have a large sample size. So all conditions are met. Okay, guys, let me show you how to perform the test. And you're going to see how straightforward this is. Be honest with you, I hear from students that they really like this chapter. If they grasp, the chapter 7, just a little bit, they like this chapter a lot. Okay, you ready? Let me show you. Stat tests. Okay, guys, you see number 3, what it says? 2 sample Z test. That's dedicated for section 8.1. When sigma 1 and sigma 2 are known and the conditions of the test are met, this is it. I don't have data, I have summary. So, sigma 1, he wants sigma 1 to begin with, 1045. So, okay. Sigma 2, guys, is 1350. X1 bar, he gave him to us right here, guys. 4777. N1 250. And X2 bar Please stop me at any time, guys, if you have any questions. N2 is 250. And would a student please tell me which sign do I select before I calculate? First, second, or third?
First.
First, thank you. Does everyone agree, guys, with that? It's not equal to?
Yeah.
I agree too. And let's do a draw. I'm gonna see the p-value on both sides. Ooh, huge p-value. That means you're gonna fail to reject HO. So Z is negative 0.8243 and p-value is 4098. Okay, let me write down what we did. Two sample Z test. I'm gonna write the steps now, guys, that we did. Okay, step one. We put HO mu1 equals mu2, and then we put HA mu1 not equal to mu2. Claim. Then we ran a two sample Z test. So I want you to walk out of today's lesson, guys. You will do two sample Z test if sigma 1 and sigma 2 population standard deviation are known. Okay, we got Z. I don't remember what it was. Negative 0.82. And we got the p-value, which is 0.4098. So guys, if you ask me how much is this blue, half of 0.4098, and this is the other half. That's the p-value. Definitely, regardless of what alpha is, that's big. Greater than alpha, fail to reject HO. Okay, guys, and now the conclusion. There is not fail, enough evidence at, let me find what alpha was, 0.05. To, what's the magic word, guys? The claim is in HA. There is not enough evidence to what?
Support.
Thank you. To support the credit card watchdog group claim. That the mean credit card debt in both Illinois and California are different. We cannot support this claim. We're not saying we're supporting, we're saying we cannot support this claim. So what do you guys think? It's not too bad, isn't it? There you go. These are the 5 steps, guys, that you learned how to do in chapter 7. And I told you I wasn't going to change anything. We're just going to continue at the same pattern. Actually, it's becoming easier for you because step 1 is just choose from 3 scenarios only. Let's do another one, guys, and have a better feel of this. All right, let me just get this ready. Travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. So guys, if I show you Texas is number 1 and Virginia is number 2. Can you tell me which scenario is going to work for this problem? First, second, third. He says vacationing in Texas costs less than vacationing in Virginia. So would it be the first, the second, or the third? Someone says it. Let me see.
Third.
I agree. It is indeed the third. And if you're not convinced why, because that says mu1 less than mu2. And that's Texas and that's Virginia. We call number 1. Look, he called Texas number 1 and Virginia number 2. I just follow that. So let's check if the conditions of the test are met. If he asks you when you do your homework, that's how you check. Random survey, guys, so that's condition number 1. Samples are independent, that's condition number 2. Sigma 1 and sigma 2 are given, that's condition number 3. And then the sample size. Well, did he say the population are normally distributed? Yes. So 4 conditions are met. So let me write them down. And I want to list them. Sigma 1, sigma 2 are given. Random samples. Dependent samples. Populations are normally distributed. If the population are not normally distributed, guys, then the sample size must be more than 30. But here I don't care because the population are normally distributed, so we're good here. All right, it's a 2-sample z-test. Let's do it. Stat tests. I hope you agree with me, guys, that so far it doesn't sound too bad. Sigma 1 is 19. The only section where students struggle a bit with is section 8.3, samples dependent, not independent. X1 bar, let's get in from here. 234, that's the sample. And N1 is 25, guys. If you have any questions, let me know. 240. So it looks like from the sample, it costs a little bit less than Texas, but is that significant? That's what we need to find. Difference between 234 and 240, is it a significant difference? Well, the test will tell us. And you guys, you have to look for this right here. I like to hit calculate to show you the p-value in action. The draw, actually. So it's a huge p-value, guys. So z is 0, z negative 0.91. Please do it again when you go home, or not when you go home, you are at home, but do them later, just to make sure that your answers match with mine. That's bigger than alpha. I don't care what alpha is. It doesn't go above 10%, so that's bigger. Fail to reject H show. And let's write the conclusion. There is not enough evidence at the 0.01 level of significance to support the travel agency claim. So probably they're lying about us. That the average daily cost of meals and lodging for vacationing in Texas is less than that of Virginia. That's it. Any questions, guys? And in summary, I'm just going to do one more example, guys. And as I promised, I want to do another one, another section. Excuse me. Summary. Perform a two-sample z-test for the difference between two means with independent samples when sigma 1 and sigma 2 are known. That is section 8.1. I'm just going to do one more question to enforce those two that we did, guys. And can you guys guess what is it going to be for the next section when sigma 1 and sigma 2 is not known? It's going to be called two-sample what? Dr. Smith would like to determine if there is a statistically significant difference between her two math 1800 classes. To make this comparison, she will compare the results from exam 1. Class 1 had 33 students take the exam with the mean of 82.6. And you see it says a population standard deviation. So guys, N1 has a mean X1 bar. You know what, why don't I write them, write that down? So just question 1 here. N1 is how many? 33 students. X1 bar, you have two sample means, remember guys, 82.6. And population standard deviation, sigma 1. It's called sigma, but because I have two of them, guys, I have to label them as sigma 1 and sigma 2. This is a class 1. Let's go to class 2. N2, X2 bar, and sigma 2. And then we need alpha. Class 2 had 31 students. Mean is 84. And population standard deviation is 3.63. Can Dr. Smith conclude that there is a difference in the mean test grades between the two classes? So there is a difference, guys. You agree with me? It should be this. Difference means not equal to. And what did he say? Alpha is 0.05. Okay, there you go, guys. Two sample z-test. Let's run it together. If you have your calculator, please grab it. You see, they didn't tell us that the populations are normally distributed, which is fine because the sample size exceeds 30. Only when the sample size doesn't exceed 30, we have to make sure that the populations themselves are normal. Now, what do you mean by two population here? Population of class 1 and population of class 2 method. So class 1 and class 2, these are the populations. So sigma 1, let me just put them on this side, guys. It's 1.41. Sigma 2, 3.63. Please do it with me. X1 bar is 82.6. N1 is 33. X2 bar, guys, is 84. And 2 is 31. And we need to check if there is a difference. looks small. So the test statistic Z is negative 2.01. If I round this to 2 decimal places, guys, you go to 0. The next number is 9, so you have to up the 0 by 1. Negative 2.01, that's the algebra that you need for this chapter. And let me write the p-value and put the calculator on the side. 0.0445. And you guys agree with me, this is less than 5%. So reject H. Sure. And why it is less? Let me show you how I would figure this out. 0 is the same as 0. 0 is the same as 0. Then the second digit after the decimal point is 4, and the second digit is 5. And we know 4 is less than 5. Just put less than. Stop. That's it. There is enough evidence to support at the 0.05 level of significance. I'm going to write the statement to support the claim. Okay, let me see what the claim is. That there is a difference in the mean test grades between the two classes. That there is a difference in the mean test grade between the two classes, guys. So we can support the teacher's claim here. That concludes section 8.1.